The next step is we are going to analyze this blade to certain loading conditions. So for this next step we are going to utilize Abacus. Abacus is well known for its advanced composite simulation capabilities. Abacus simulation capabilities include the ability to do ballistic impact on composites, barely visible impact damage, BVID simulations, composite beam crushing, debonding using VCT, delamination using cohesive elements, and other capabilities. Today we are going to look at bird strike on this blade. So this is the blade that we have in the CATIA. We have all of our ply definitions already done, and we're going to export the blade with its ply definitions into the Abacus environment. So we are going to export the entire stack, and we're going to do the actual ply orientations as they've been draped. So we're going to export this to a layup file, and this layup file is a neutral file. It's actually a text file that we can then directly read into the Abacus CAE environment. So what we're looking at now is the Abacus CAE environment. So we have our blade geometry already imported in. We also have a bird model. So this is an ellipsoidal shape to represent our bird, and we have the bird properties already defined. And what we're going to do is we're going to simulate the impact of this bird on the leading edge of our composite blade. So the first thing we're going to do is we're going to create a new layup. This is a layup that's going to reside within the Abacus environment. And now we're going to map that layup. We're essentially going to import the layup that we exported from CATIA into our Abacus model. So when we do that, we see that we have all of the plies that we had defined back in CATIA now in Abacus and mapped onto our Abacus mesh. So we had previously meshed this model, and now these plies and their relative orientations are defined on that model. So inside of Abacus we have our own composite GUI manager that we're looking at now, and we can use that to verify that our plies are in the proper orientations, that our material, our coordinate systems are correct. And we can also do a ply stack plot, which is the ability to pick a particular element and verify the ply stack sequencing. So we can see that we have 8 plies in this particular plot. We can also turn on our material names and see the different materials that we have defined for each of those plies. So the material definitions that we defined in CATIA got translated into Abacus as well as the ply orientations. So now that we've verified the model, we can start setting up the loading condition. And the first thing we're going to do is define contact. In Abacus we have what's called general contact, where we just want to tell the software that there's going to be contact, and it goes and it figures out where there's contact. The next thing we're going to do is define our boundary conditions. So this first boundary condition is just going to be essentially fixing the root of the blade. So we're going to put that fixed boundary condition on the root of the blade, and then we're going to define a predefined field, which is essentially we're going to define an initial velocity for that bird. So we're going to define, choose that bird geometry, and say we're going to define an initial velocity for that bird, and we're going to give it some initial velocity both in the 1 direction and the 3 direction. And that's all we have to do. The model is now set up and it's ready to be analyzed. So we're going to create a new simulation job. Now we're going to call it impact, and we're going to perform the analysis. So this takes a few moments, so we're going to go right to the results of our simulation. And we can see that the bird, when it strikes the composite blade here, the leading edge, that actually penetrates through that leading edge, causes a lot of damage, and actually starts tearing and destroying the composite. So what we're going to do is we are going to reinforce our composite blade to be able to withstand that impact. So we're going to create a new set of elements here of where we want that reinforcing ply. So we're just going to visually select those on the screen. That we're going to have this reinforcing ply on the leading edge. We're going to remove the elements on the trailing edge there. And then we're going to go into our composite ply manager, and we're going to edit our current ply definition. We're going to go to the bottom here and add a new ply, which we're going to call reinforcement. For the region, we're going to select that region that we just chose for our elements. We're going to define our material that we want to use for that, and I've defined a reinforcement material. We're going to define a thickness and then a rotational angle, and we're just going to choose 0 degrees. So once we have that defined, we can copy. We're actually doing a symmetric layup copy. So now instead of just a single ply of reinforcement, we now have 8 plies of reinforcement there. So we're going to go back to our simulation job, create a new one called impact reinforced, and we're going to go ahead and submit this simulation. So again, it takes a little while to run. We're going to skip right to the results. And now we can see that we still have the impact, but we don't have penetration of the bird through our composite panel. So we get impact, some high stresses, but our leading edge stays intact. So now we're finished with the simulation. Essentially, the analyst has created a new ply layup that will withstand the operational loads. So we're going to export this from Abacus, saying this is our new layup. This is the one that's going to withstand our loads. When the analyst does that export, the designer now can bring in that new layup definition back to the CATIA environment. So we're going to go ahead and grab this exported layup definition, bring it into the CATIA environment, and we can see that we have highlights of these added plies. And the designer can go ahead and accept those new plies, and it automatically updates his CATIA model. It shows you what has been added. That's the ply that has been added. And we're going to go ahead and say OK. And the plies have been imported and are now part of the layup in CATIA. So that was a quick look at Abacus and looking at the simulation of a bird strike into a composite blade. If you'd like more information or more details about advanced simulation capabilities, advanced composite analysis, go ahead and you can visit us at simulia.com, and we have other webinars with a lot more detailed information on that site. Thank you.